Hello, everyone, and thank you for joining us today for our HashiCorp Solutions Engineering Hangout, hosted by Roger Berlin. Today, we're going to talk about HashiCorp Terraform Cloud. Terraform uses infrastructure as code in order to provision any cloud infrastructure and service. Roger is going to discuss one of the most important features of Terraform Cloud, which you'll also hear us say TFC, Sentinel. So Sentinel lets you implement governance policies as code. He'll discuss how you can use a common set of Sentinel policies stored in a version control system, such as GitHub, across multiple TFC organizations. I also want to note that this Hangout is recorded, and the recording will be made available after post-processing, usually within about a day or two. I'll email it out to all of you. The demo will be about 20 minutes, and then we'll allow up to 30 minutes afterward for questions. So please go ahead and submit your questions throughout the demo through the GoToWebinar portal, and then we'll answer them at the end. So with that, let's go ahead and get started. Take it away, Roger.
Okay, thanks so much, Amanda. Thank you to all of you for joining. Happy to be doing this today. So Amanda already pretty much described what I'm going to be talking about, but I will, and you can see here my title and email, which will be at the end of the presentation as well. So I'm going to go in and talk about my two objectives for today's presentation and demo. The primary objective is to show how Sentinel policies can easily be used across multiple Terraform Cloud and Terraform Enterprise organizations. This leverages TFC's VSC integrations, version control system integrations, and policy sets. By the way, just for clarification, so there's been some renaming recently. We used to talk about Terraform Enterprise, and there was a cloud version or a SaaS version, and then the enterprise version or the private version. But the way we talk about it now, Terraform Cloud is the application. We have a hosted implementation of that at app.terraform.io, but then Terraform Cloud as an application is used by the Terraform Enterprise, you know, the self-hosted implementation that people can run either on-premise, you know, on VMware, or in their own virtual private networks in the three, you know, Amazon, Azure, and in Google. So generally speaking, I'll talk about Terraform Cloud here, but anything I say does apply to Terraform Enterprise as well. Having said that, a secondary objective is to show how GitHub Actions can be used to automatically run Sentinel Simulator test cases against policy sets, you know, within the VCS repository that you modify during pull requests and that you're trying to merge into the master branch. So it's a pretty neat thing. The benefits of this are that, first of all, of course, by storing your Sentinel policies, and I'm going to talk in a minute about what Sentinel is more, but by storing the Sentinel policies in a VCS repository, you get the standard VCS benefits, including version history, change control, and collaboration. But then you also get some other benefits, which is or are sharing policies across multiple organizations without having to edit them multiple times, and also ensuring that modified policies pass your Sentinel Simulator test cases before you merge them. Okay, so that's kind of the objectives and the benefits. The agenda or what I'll go through in order is a little bit about what Sentinel is and how Sentinel is used in Terraform, because I think those are important things for everybody to understand before I do the demo. And then I'll talk about how you can manage Sentinel policies across, you know, one or more organizations. And then I'll do the demo to show that. So what is Sentinel and how is it used in Terraform? Sentinel is a framework for implementing governance policies as code, and that's very similar to the way that Terraform implements infrastructure as code. So I assume that most of you are presumably familiar with Terraform, at least the open source version, if not Terraform Cloud and or Terraform Enterprise. So Sentinel is governance as code. Sometimes you'll hear the phrase policy as code. It includes its own language and is embedded in HashiCorp's enterprise products. So you wouldn't use this with open source products, at least not yet, or not generally, but definitely with the enterprise products, the commercial products. Using Sentinel ensures that your governance policies are actually being checked, as opposed to just being listed, you know, in some document like a spreadsheet or a Word document, right? It's nice to have policies listed somewheres, but that doesn't enforce them. Sentinel actually will enforce your policies. It does that with fine-grained policies that use conditional logic, so you can do fairly sophisticated processing or, you know, checking various types of conditions. And it includes a simulator that allows you to test your policies. So now let's talk about how Sentinel is used in Terraform. Sentinel policies are checked between the standard plan and apply steps of runs in Terraform Cloud. So I'm sure anybody using Terraform open source would be aware of the plan and the apply steps. Terraform Enterprise and Terraform Cloud add in Sentinel policy checks and something else, another step called cost estimates, which I'll show as well. So policies have different enforcement levels. Those levels are advisory, soft mandatory, and hard mandatory. The difference between soft mandatory and hard mandatory is that soft mandatory policies can be if there are violations, those violations can be overridden by users with sufficient authority. And those users would be people who are members of the owners team within the organization, or people who are members of a team that have the managed policies permission. Sentinel policies in Terraform can evaluate the attributes of existing and new resources based on information associated with the current run. And that includes the plan, the configuration, meaning the Terraform code, the current state of the workspace, and other run data, including cost estimates and some workspace metadata. So doing all this ensures that your resources comply with all policies before they are provisioned. So that's the benefit of Sentinel, is that it's going to help you restrict your resources. And I'm going to show you. I'm going to obviously show you some policies as part of the demo. But speaking a little more generally, some of the things you can do are restrict the sizes of VMs, mandate that certain labels be present, prevent, let's say 0.0.0/0 as a seeder on a security group rule, restricting the size of various clusters, requiring that S3 buckets be encrypted with a KMS key and use the private ACL. And obviously these are similar things that you could do for Azure and Google and AWS, VMware, things like restricting the amount of memory and CPU assigned to a virtual machine in VMware, or restricting the size of a virtual disk in VMware. So there's all kinds of things like that that you can do that are very useful. And restricting the cost. By looking at the cost estimates, you can ensure that that the provisioning that somebody is doing is not going to cost more per month than what you consider reasonable. Okay, so let's see. This is a graphic showing how Sentinel fits into the whole workflow of using Terraform Cloud and Enterprise. Generally speaking, what you're going to have is a VCS. You're going to have some Terraform code sitting in a VCS repository. And when there's a pull request on that or a push, that's going to trigger a plan within a Terraform Cloud workspace. Within Terraform Cloud workspaces can be pointed at VCS repositories or at specific branches or directories within them. So we'll have a plan triggered, and then if the plan succeeds, then that will automatically cause Terraform Cloud to start invoking all Sentinel policy checks that are configured for that workspace. And if all those Sentinel policy checks pass, if there's no violations, then the apply can be done to actually provision the infrastructure. Now, as I mentioned, it is possible for certain users to override the soft mandatory policy checks, but nobody can override the hard mandatory policy checks. Now, if cost estimates are enabled on the workspace, that's something you do at an organization level. So if cost estimates are enabled, they would occur between the plan and the Sentinel policy checks. And we can see that here. This is a screenshot of the Terraform Cloud UI of a run that was done in a particular workspace. And we can see the sequence, the full sequence is plan, cost estimation, policy checks, and apply. And then we can see the audit trail of who did it. It was R. Berlin as me. I confirmed this run 5 days ago. So there's other things, by the way, here as well in Terraform Cloud and Enterprise. There you can see there are tabs up at the top here for maintaining state. We maintain the full history of the state for the workspace. There's setting variables, both Terraform variables and environment variables in various workspace settings. That's useful to know about as well. Okay, so Sentinel Imports. An import in Sentinel is basically a way of allowing Sentinel to do certain things. You can think of it as a module. It's a module of Sentinel code that extends Sentinel's capabilities, or a library. So Sentinel does include several standard imports for processing different kinds of data. So there's strings, JSON, decimals, SOC ADDR, things like that. But Terraform adds some additional imports that give Sentinel data about the current run. And in particular, these 4 imports: tfplan gives access to the Terraform plan, tfconfig gives access to the Terraform configuration, tfstate gives access to the current state of the workspace, and tfrun gives access to workspace metadata and the cost estimate data. Now, in addition, one more point here, and this is relevant to the use of the Sentinel Simulator, is you can generate mocks from a plan in Terraform Cloud, and there'll be one mock for each of these imports. So you can, from the Terraform, from the plan in the Terraform Cloud UI, or using the Terraform Cloud API, you can download a zip file with the mocks and then use those mocks with the simulator. And I actually did a HashiCorp talk a few weeks ago about that topic, and I have a link to that. Well, I don't think we have the slides up yet, but eventually we'll get you, make sure you guys have links to that HashiCorp talk. I think I have a link to the presentation, to the announcement of the talk. So that's another interesting topic in its own right. And one of the things I'd forgotten to mention at the beginning, that I meant to indicate that I'm essentially one of the leading Sentinel specialists and Terraform specialists, within the company. I work as a solutions engineer, but kind of my expertise is on Sentinel, and I actually wrote a white paper or a guide about writing and testing Sentinel policies for Terraform, and that's something that I'll give you the link to later as well. So I've done a lot. I've done a lot with Sentinel and a lot with Terraform. Okay. So having covered the basics of what Sentinel is and how Sentinel is used in Terraform, let's move on and talk about how you can manage Sentinel policies across multiple Terraform Cloud organizations. So this screenshot shows the old way of managing policies, which was in the past, you essentially had to edit the policies in the UI itself. So you would come into this little window down here, and you would, paste in, either type directly into this little window, or you would, maybe type your Sentinel policy somewhere else, and when it was all done, you would paste it in. And so that was not ideal. And apart from kind of just not being the best editor, the other issue was that if you wanted to use the same policy in more than one organization, you had to enter it multiple times. And if you made a change to that policy, you then had to update it multiple times, right? So that's just not really good. So the new and better way, which has been a 2-step improvement, is at the end of 2018, we introduced something called policy sets. These were added, and they allow groups of policies to be selectively applied to workspaces in an organization. But they still use policies edited within the TFC UI. So it was good that you could now apply a group of policies against a workspace as opposed to applying policies one at a time, but you still had to edit them in the UI. But a few months ago, we did release something called VCS-enabled policy sets. And now what you do is you actually store your policies and your policy sets in a VCS repository, and we support GitHub, Bitbucket, and GitLab. And now you point the policy set in the TFC UI, you point the policy set against the repository. And you can also specify the VCS branch and a policies path. In other words, you can point to a subdirectory of the repository. That means that you can have multiple policy sets within a single repository, and you'll see that during the demo. So this gives better versioning of policies. You can maintain the history of the policies, and it enables the same policies to be used across multiple TFC organizations. So here you see a screenshot of what the new policy set looks like. You don't edit policies anymore in the UI, but you do configure the policy set. And in the policy set, you point to, what policy set source you want to use. I only have one here. It is possible to upload them through an API as well, but in my case, I selected GitHub. That's why it has a purple outline around it. We can see our Berlin Sentinel policy sets for TFC. We even see the most recent commit, which commit we're using here, with a link to that, and when I last updated it, or relative to when I captured the screenshot. We see the repository here as well, and there's additional options down below which can show us the policies path and the branch. Okay, so with that, I'm ready to do the demo. I want to mention that all required artifacts for the demo are in two different repositories here. The first one is the actual Terraform code that I'm using in my workspaces for purposes of running plans and applies, although I won't actually do any applying today, but I will do a plan. And then the second one is the more important one. That's the one with the Sentinel policy sets, as well as the GitHub action workflows and action. So before I do the demo, though, one more slide is just to kind of outline what I'm going to show. I'm going to show how policies stored in a particular GitHub repository, the second one, can be shared across two Terraform Cloud organizations. I'll show how Sentinel policies can restrict the provisioning of VMs. And when I say VMs here, I mean EC2 instances, Azure VMs, Google Compute instances, or VMware VMs. And I'll show how changing a policy in the GitHub repository automatically updates the version of it that both organizations use. And then I'll show how doing a pull request against the master branch, or into the master branch, triggers one or more GitHub actions to run the Sentinel Simulator test cases. And an important point here is that the test cases are only run against the policy sets that have changes. So that's nice because then you're not doing excessive test cases. And also the idea there is that if the test cases fail, if the Sentinel Simulator test cases fail, that will block the merge from being done, just like other GitHub checks. Okay, so with that, let me go into Chrome and let's come over here. This is the second of the two repositories I mentioned, Sentinel policy sets for TFC within my personal organization. And we can see that I have 4 different cloud directories. If we go into AWS, for instance, we can see I have 2 policies. I won't show them to you now, but this one, restrict EC2 instance type, limits the instance type of EC2 instances to be T2 small, medium, and large. And then force mandatory tags requires that certain tags be present on all EC2 instances. This is the configuration file. Sentinel HCL is basically for the policy set, is saying what are the policies that are included in it without the .sentinel extension. And then we're saying what the enforcement level is. So this one is soft mandatory. This one is hard mandatory. So that's the AWS. Similarly for Azure, we have 2 very similar policies. We also, by the way, have test cases. I forgot to show that to you for AWS, but we have test cases that correspond to those policies. There's a fail test case that uses one of the mocks that I mentioned. So the fail JSON test case uses the mock tfplan fail mock file, and then the pass test case uses this mock file. So we have that for both AWS and Azure, and then we have similar stuff for GCP and VMware, right? GCP, we see 2 policies, test case and Sentinel. And for VMware, it's almost the same, except I only have 1 policy. There's not really a concept that I saw for tagging VMs in quite the same way, or at least it's not as direct. It's through a separate resource. So I didn't include the tagging policy. Okay, by the way, the slides that I showed before are in this repository as well, and a README that gives you some information about this. So let's take a look over at the Terraform Cloud UI. Now remember, I have 2 organizations. This one is Roger Berlin Policy Set Demo 1. This one over here is Policy Set Demo 2. And you can see that they have the exact same set. They both have 4 policy sets called AWS, Azure, GCP, and VMware. And if we go into one of these and look at the properties, the expanded properties, first of all, we can see that these are pointing at the repository that I just showed you. We see that the AWS one, the policies path is set to /AWS, so it gets policies out of the AWS directory, right? That AWS directory over here. And we also we see the VCS branch. I'm just using the default branch, which in this case means the master branch. And I'm saying policies are enforced on selected workspace, and I'm enforcing the AWS policy set on an AWS EC2 instance to workspace. And we can see that over here. We can see I have, in each of these organizations, I have 4 workspaces, each of which provisions a VM of the relevant type. So I have AWS, Azure, GCP, and VMware. That's in organization 2. And over here I have the same thing in organization 1, but I gave just different names so that it would help me realize which one I'm looking at. Okay, so we have our policy sets, and we have the workspaces. So what we can do now is just to show you Sentinel in action. What I will do is let's go into. I could use any of these, but I'm going to use Google. And what I'm going to do is first of all, on the variables tab, I'll show you that I have several Terraform variables set. These correspond to the Terraform variables within the main.tf file for this, for that workspace. We have GCP project is the name of the Google project I'm using, the instance name, and the machine type. Notice this is N1 standard 1. Now I should mention the current Google policy. Why don't we take a look at that? If we take a look at the current Google policy that restricts the machine type, this one, and I'm going to skip over a lot of this stuff, but down here at the bottom, we actually have the allowed types. N1 standard 1 is there, but it's commented out, right? So the only allowed types right now are standard 2 and standard 4, N1 standard 2 and N1 standard 4. Okay, so right now that's going to violate the policy, obviously. I also have environment variables, which are confirm destroy, which allows me to destroy whatever's in a workspace, things that have been provisioned, and my Google credentials file. Note, by the way, that in Terraform Cloud and Enterprise, you can mark variables as sensitive. In other words, they're write only. So after the person who adds that variable and they mark it as sensitive, nobody can see that anymore, not even the person who added it. By the way, if you use Google and Google credentials files, you have to remove line breaks from anything before you add it as an environment variable. So keep that in mind. Okay, let's do this. I'm going to queue a plan. I'm going to say demo, and I'm going to say demo N1 standard 1 to keep that straight. We'll queue a plan. Fortunately, Google's pretty fast. The plan will probably take about 30, 40 seconds to run. And we can see now the plan is queued, and there's also policy check and apply are queued. I don't have cost estimates enabled here. I just didn't need to bother with that for purposes of this demo. But we can see that I'm provisioning this, Google Compute instance, right? We have Google Compute instance being provisioned over here, and after that's provisioned, we now have the policy check soft failed. So we see the two policies were run. The enforce mandatory labels was okay, but the restrict GCE machine type failed. And we get a very nice message here. This one here is saying, sorry if I can, sometimes it's tricky to highlight these things, right? Yeah, okay, I'm having problems. Let's do this. Sometimes if I collapse it and then try again. No, it won't let me. Anyways, resource Google Compute Instance Demo 0 has attribute machine type with value N1 standard 1 that is not in the allowed list, which consists of N1 standard 2 and N1 standard 4, right? It's a very explicit message. Now, that's something that I had to add into the policy itself to make it that explicit, but that is something that, regardless of what instance fails, that will notify you. And that's an important thing to do in Sentinel policies. You want to give the person who violated the policy enough information so that they can know what they have to fix. So anyways, we see that failed. Now, because I'm a member of the owners team of this organization, I actually can override that failure, because what's happening here is N1 standard 1 is actually smaller than these guys, right? So presumably the people who put this policy in place are trying to avoid expensive compute instances. So they're not really going to object to N1 standard 1, right? So I could put in a comment here and say, well, N1 standard 1 is even cheaper, right? And I could override that policy check failure. And now I could go ahead and confirm and apply if I wanted to. Notice it does say we'll have an audit trail of who did the overriding. I'm just going to discard that run though, right? I don't really care. Now, I don't need to apply it. What I could do here is I could go change this, but to N1 standard 2, and then we would see that both policies would pass, but I think you'll believe me on that. I'm not actually going to do it. What I'm going to do instead is I'm going to go back to GitHub, and I want to illustrate what happens when we change policy sets. So let's actually change this one. Let's decide that the governance team or the security team decides that. Now notice I'm on the master branch. Normally you wouldn't make changes on the master branch, but I'm doing this on purpose. Let's say I come down here and the governance team has decided, you know what, we'll allow N1 standard 1 as well. So we can say allow N1 standard 1, 2, and I can now say commit directly to the master branch. All right, so when I do that, okay, and I come back here and I look at GCP, notice that this now says it just changed. Last updated a few seconds, right? And this one, GCP, in the other organization says last updated a few seconds ago, right? So both of these were updated. That's a little, if I refresh that, that's actually kind of funny that I captured it so quickly that it actually said in a few seconds. There might be a timestamp difference. So anyways, last updated a few seconds ago. So we see that now, because I committed directly to the master branch, if I were to run that, if I were to run this again, and actually I will run it again and we'll come back to it later to see, demo with revised policy. If I run that now, it doesn't matter which org I'm in because they both have the same thing. Now this would pass the policy checks. But now let's assume that the same thing happens with Azure and Amazon AWS. Let's assume that the governance team says, you know what, we should really allow smaller types for AWS and Azure also. And what they decide is they decide to do this the right way, which is to create an AWS Azure branch from master. And of course, maybe they'd be doing this on the command line as well, but they're going to go in here, they go into AWS, they find the AWS policy, and they're going to edit this one. Now remember, now I'm not on the master branch anymore. Okay, so we come down here, I add T2 micro, and I can say allow T2 micro, and I commit that to that new branch. Okay, and then we go back up here and we say, hey, we also want to allow a smaller Azure policy. So I come in here and I go to the restrict VM size policy and we scroll down. Oh, sorry, I better edit first. I scroll down and I allow basic A0. So allow basic A0, commit to the modify AWS Azure branch. And now having done that, if I come back up here, I'm prompted with the standard GitHub thing saying that, hey, there's changes to a branch, and now I can compare and do a pull request on them. All right, so I'm going to say allow smaller types for AWS and Azure. Maybe this should be smallest. Actually, they're not the smallest necessarily, but I'll say smaller. Okay, now I'm going to create my pull request. And this is where we're going to see the GitHub Actions come into play. And I probably should have shown you what the GitHub workflows in action look like, but I'll come back to that after this happens. So create pull request. Now momentarily, this does actually say, it looks like the merge pull request is enabled. I guess if you were really, really quick, you could merge it. Notice now it's not enabled. There's a bit of a lag there, but so it was temporarily there, but now what we have is we have details for these two workflows that are being done. I have Sentinel test AWS and I have Sentinel test Azure. And notice though, only for those two, right? Only for the two that I modified. I don't have workflows happening for GCP or for VMware. So what's happening here is first the job gets set up within these workflows. Then the Docker, this uses Docker containers, so a Docker container was built. Then the code of the repository is checked out into the Docker container, and then the Sentinel test cases are run. Now in this case, it's the Sentinel test cases for AWS. And we see here the results. We see that both of the policies passed both of their test cases and the job is complete. Over here, we can see the same thing for Azure, right? We see the Azure test cases ran and everything's good. They passed. And when we come back to our pull request, and maybe I'll just close these tabs. If I come back here and if I refresh, right, now this says show all checks. They were both successful and I have no conflicts with the base branch, so I can go ahead and merge my pull request and confirm it and delete my branch. And again, if we come back to the policy sets, if we come up here and look at AWS, we're going to see last updated a few seconds ago, and the same thing will be true here. Let's say if I look at Azure, last updated a few seconds ago. Whereas if I were to look at VMware, there won't be an update. VMware is going to say last updated 4 days ago. By the way, just to avoid confusion, this whole time when I talk about the update, the timestamps changing, I'm looking at the git commit timestamps. This date up here kind of refers to the configuration settings. In other words, the settings that you're changing within the screen. So those dates are different. I'm going to wrap up the demo, but let me finally just do this. Let me show you the GitHub action workflows and the action. So that's under the GitHub directory. The workflows look like this. I'll just show one of them. AWS pull request YAML is basically giving a name to the workflow. It says this is done or executed in response to pull requests against the master branch or into the master branch, but only for code or files that are changed on the AWS path or anything underneath it. And then the job that I'm running is called Sentinel Test AWS. It runs on the latest version of Ubuntu inside a Docker container. It checks out the code. Then it has this actual Sentinel Test AWS, which uses this GitHub action that's also in the same repository. I pass in an argument /AWS, essentially the AWS directory, and I also pass in my GitHub token. The way the action looks like this. There's three files. There's a Docker file, an action YAML, and an entry point sh. I'm only going to show you the entry point at the very beginning, which is that it's CDing into $1. In other words, it changes into the AWS directory or the Azure directory or the GCP directory. And then this is the main command inside the Docker container. It's running Sentinel test against the policies in that directory. And then the rest of it is just collecting the output and letting GitHub know the status, whether or not the check was successful or not. So that's it. So with that, I'm going to stop. I think that was a little over a half hour. So I'm ready to answer questions that any of you might have been asking during the past half hour or any that you might still ask during the next 15 or 20 minutes.
Thanks, Roger. Great demo. Okay, so just a reminder, as Roger said, if you do have any questions, please go ahead and submit them in the portal and we will address them. So Roger, first question, kind of a starter question. Someone's asking if they're just getting started with Sentinel in TFC, where do you recommend them getting started?
Sure, it's a very good question. One place, I'm going to point you to three different things, which I just happen to have anticipated your question. I wonder if this was a planted question. No, I presume it was real. So three things, maybe in order. I think the first thing to look at would be the Sentinel overview documentation. So assuming you're starting to use Terraform Cloud or Terraform Enterprise, underneath in our documentation, we've split, there's been changes recently. So Terraform CLI refers to the Terraform open source documentation. Terraform Cloud has everything you need to know about the Terraform Cloud application itself. So if you're using our hosted implementation at app.terraform.io, like I used during the demo, that's what you would look at. Terraform Enterprise is really just more about managing and installing, or vice versa, installing and managing your dedicated Terraform Enterprise instances that use Terraform Cloud. So if you go into Terraform Cloud, which is where I was, you can open up Sentinel, and then you can kind of start reading through the Sentinel overview and these various topics underneath there. Now, if you actually start writing policies for real, as opposed to just using them or consuming policies that other people have used, you're going to want to look at docs.hashicorp.com/Sentinel, which has extensive reference about Sentinel, including the language. There's various information about the language, including a detailed specification. There's also some built-in functions that are documented and some standard imports that I mentioned. So I mentioned the JSON and the strings, and I think I mentioned sock ADDR. I might have mentioned decimal, right? So these are the standard imports. Finally, two other sources of information. If you're looking for sample Sentinel policies for Terraform, in the HashiCorp Terraform Guides repository, there's a governance section, and then second generation are the more recent policies that do more advanced things, like printing out the full address of resources that violate policies. And so you'll see second generation, there are policies for AWS, Azure, some cloud agnostic ones. There's some common functions that can be reused within policies. And then there's GCP and VMware. So there's quite a few example policies there. And then finally, this is the white paper I mentioned, or the guide that's on the HashiCorp website, which is a very extensive guide that gives advice about writing and testing Sentinel policies for Terraform. And all these links will be at the end of the presentation. And this, by the way, it does include 5 exercises as well. So there's 5 exercises that you can kind of go through, and there's solutions repository. Sorry, go ahead, Amanda.
That's okay. We'll include that link in the follow-up email with the recording.
And I probably should have just jumped forward. These are the links. So Anybody who wants to capture a screenshot of that or take a photo of that can do that now. That will be useful for you. You know,
And then
or
Roger,
you'll have this ultimately.
yeah, Roger, the next question is, someone's wondering, is it possible to write Sentinel policies that only apply to specific team members and not others?
Um, Not at this time because Sentinel policies are applied to workspaces, right? So we can see when we look at the configuration. Oh, by the way, we see now that the policy check passed, right? Remember I reran, so both of them passed. When you look at policy sets are applied to either all workspaces or specific workspaces. Now, um, it might be possible with, right now we don't include the user data, like the user who triggered a run. That's something that could be done. That might be a valid enhancement request. If we look at the TF run data, it includes the name of the workspace and some other data. I did recently open up an enhancement request asking for some additional information, and I think I might have asked for the identity of the person who triggered the run, because then you could imagine your policy looking at let's imagine that there was a user here, the person who triggered the run. Then you could basically say, hey, you know, check the user, and if the user is this person or that person, skip the rest of the policy check. So that is hypothetically possible. It's just not possible today.
Yeah. Okay. Yeah. Something that might come. Okay. And then the next question. So someone's asking, can we create policies that would check for Terraform best practices? So for instance, check Terraform files to make sure that variables are in a file named variables.tf for a given
Yeah.
module, all modules in a repo.
That's a really good question because this just came up yesterday with somebody. I was answering a question internally about some confusion because somebody wanted to do something kind of similar, a little different, which is they wanted to control override files. And here's the situation. I said earlier that the TF config import gives you essentially access to the Terraform code, but it's not quite the code itself. It's not the files with the code. It's the Terraform configuration that is generated from those files. So unfortunately, while the Terraform configuration, you can see here what it has access to. It has access to the modules and provisioners and outputs and providers and resources. In other words, when you get into this part here, you can actually look at the actual code associated with the resources. So if you're looking at a resource and you want to know whether or not, the actual thing passed into something was, var dot user or var dot whatever, you can access what the actual code was. However, we don't give you access, we don't tell you, or Sentinel won't know what files the code came from. It just knows the final, effectively compiled code or execution. I guess I'm not sure what the correct terminology is, but it does not know the file names, unfortunately.
Okay. Okay. And then next question, do you have an example of how to check your Sentinel changes with GitLab, say as opposed to GitHub?
I don't right now, but one of my colleagues, Kausar, is actually working. I think, Amanda, you might have seen, he's proposed or will be proposing a webinar because he asked me about this yesterday that will do something related to Terraform. And he's going to use GitLab and he's going to try to do what I did with GitHub Actions. He's going to try to see if he can do the same thing using whatever the comparable feature is of GitLab. So certainly we do, if we go back to the documentation, our VCS integration does include GitHub, GitHub Enterprise, GitLab.com, GitLab EE and CE, Bitbucket Cloud, Bitbucket Server, and Data Center, right? So certainly GitLab, you can do pretty much the same things in terms of having your policies be in GitLab. Well, Amanda, was the question actually just about having the policies be in GitLab, or was there anything about restricting something related
I
to
just
GitLab?
said an example of how to check your Sentinel changes.
Yeah, it would be, check mean with the simulator. That's something hopefully we could do with whatever, I don't know GitLab well enough, but I'm presuming that they might have something similar to GitHub Actions. In other words, that whatever you can do where you can configure some kind of check between the time that somebody does a pull request and the time the merge button is enabled, hopefully you can do the same thing. So look for a future webinar from us where we might have that demonstrated.
Well, keep your eye out. And then, okay, so next question, we have a few more to get through quickly.
Sure.
What is a use case for hardening and compliance policies?
Um, Well, the policies, like I said, various examples, the ones I showed you are about doing things. A lot of policies, I think there's two broad categories of Sentinel policies in Terraform. One is cost reduction or avoiding excessive costs. The other one is adhering to security concerns. So for instance, the ones I showed you about restricting the VM size, that's clearly what nobody cares about VM size except that it costs more money, right? That's why people do those policies. Things like restricting labels or mandating that certain labels be present, that's more of a managerial kind of thing. But then there are security concerns that people can have. For instance, restricting security group rules so that you don't allow outbound, security group rules beyond a certain amount of fixed things. Also inbound rules. So I worked with one customer that did an extensive amount of work. I helped them write Sentinel policies to restrict their security group rules in Sentinel in the same way they had been doing with their own homegrown tool. So those are the two primary use cases. There probably are other things as well. You could try to with the TF config import that I showed briefly before. You could try to restrict certain coding practices. Here's an example. Somebody's working on this right now. I've been helping him. Remember the TF config import has access to your providers, right? Here are your providers in here. Let's say that a best practice for providers in general is not to pass your cloud credentials as Terraform variables, because that could end up being checked into source code management. And they also can end up in the state files and things like that. So the best practice is to use environment variables. So one way you could mandate that there not be, that somebody not include, let's say, their AWS keys specifically within the AWS provider would be to examine the AWS provider in the TF config with the TF config import and not allow the access key or the secret key attributes to be present within any of the AWS providers, right? That's a way that you would enforce a coding standard and a best practice with the Sentinel TF config import. Go ahead,
Hey,
Amanda, sorry.
Roger, you mentioned when you were walking through kind of the types of Sentinel policies, you'd mentioned cost estimates. So we actually got a question on that.
Sure.
Someone's asking, can you implement a policy that checks total cost estimates across your organization, or a policy set over a period of time that takes into account multiple workspaces?
So no, it's important to understand, that's a good question. It's important to understand that each policy check is done against a single workspace at a time. And that's going to be done against, the cost estimate is for the workspace. It's for the resources being created or that currently exist within the workspace. Now, there are these three things you see here. There's the prior monthly cost. If you're doing a plan against a workspace into which you had already provisioned some resources in a previous run, you will see the prior monthly cost, and you could see the proposed monthly cost, and then you could see the change in the monthly cost. And those are the three things that are available to you. Now, there is one thing you could do is, remember, you can use the TF state import to test existing resources. So you could periodically schedule runs against your Terraform workspaces, even all your Terraform workspaces, to test your current state. And those runs actually would do a cost estimate, because effectively they would do a plan and a cost estimate, and then you would evaluate the current state. So you could schedule runs and Terraform Sentinel policy checks. It's a little bit kludgy in the following sense, is that then you end up with these extra runs that you maybe don't really want. However, there is one useful feature, which is that Terraform runs have a notion, and I may not have it right here, but there's a notion of something called a provisional run. I don't have it here, but there's something called, it's either called provisional or it's called speculative. Sorry, it's called speculative runs. So for instance, when you do certain runs, I think this says it somewhere here, a speculative plan, you actually can launch what's called a speculative run, and those runs don't show up directly in the UI. You end up, when you do a speculative run, you get a link that you can use to view the run, but it doesn't show up in the list. And so that at least avoids a lot of clutter. So that's how I would go about doing it. I would schedule, periodic, daily or weekly runs against all the workspaces, and then I would check the cost estimates, and I would do those runs as speculative runs. Speculative.
Yeah, okay.
Here we go.
Roger, next question. This is a good question because this kind of goes into, what's possible within Sentinel, but also what that user experience ends up looking like. So someone's asking, can you soft fail require specific people or teams to approve the change? So for instance, the team leader might be the only one that should be able to approve a high risk change.
Yeah. Well, there's a certain amount, it's not by person like that, but what we have is teams have permissions. So if we look at teams within an organization, I only have one team here, but we can see that there's the owner's team. And we can see that the owner's team always has all these policies, organization permissions called manage policies, manage workspaces, manage VCS settings, and then all the various workspace permissions. But here's the thing, if I were to go in here, if I were to create a new team called, oops, oh, sorry, I need to type a name, demo, create a team. Now I could give this demo team manage policies, and I could then, sorry, I could update the team organization settings. And now what I can do is you can assign teams to workspaces. So I could go into one of my workspaces and I could go into settings and team access, and I could say that the demo team has, write permission on this particular workspace. So that's how permissions are done. So in other words, going back to the question, people who are members of the owner's team or people who have the manage policies permission, sorry, who belong to a team that have the manage policies permission, those are the people who would be allowed to override the policies.
Yeah.
Sorry, they would be able to override the soft mandatory policy violations.
And so you could make a team that's just one member, right?
That's
And
true. Yeah, by using teams,
yeah.
yes, you could create teams. Just that. Very good. Thank you, Amanda. Yeah, you could create a team with just one or two specific people, and then do it that way.
And
But
like,
keeping in mind that the owners of the organization would always have the right to override.
yeah, yeah. And there's also always kind of that in between too, right? Where you can have maybe a team member, they do have the ability to approve it, but it can give them a notice saying, hey, are you sure you want to do this? Right? For
Well,
certain.
they're always prompted, right? Earlier when I tried to override right over here, well, now I can't override, but you're always given the, um, you know, I think when you click the override button, it prompts you, are you sure you want to override? Because you're given the opportunity to write a comment, right? You're supposed to, generally speaking, people write a comment indicating why they're overriding.
Yeah. Okay, so one final question, unless anyone else has one, quick get it in. So last question, Roger. Someone's wondering, how would you create a policy that checks for the usage of a specific resource? So for example, say we only want people to use our custom modules.
So that's a very good one. We have some in here. I may not have a complete example here, but let me show something from my own. I'm trying to think where I have this in a workspace. Give me 1 second here. What I'm going to do is go into, I believe I have it here, and I really need to add this into that other. Fortunately, I think I have the policy here. I think I have it here. Give me a second here. What you can do effectively is this, and I'm not seeing it here, all resources from PMR. So we have something which we have not talked about called the private module registry. So that's where if I go back to a different tab, you have the modules. So I don't have any there, but here I can do it here. Open link in a new tab. Here we have in my cloud operations organization, I have two modules. This is a modules registry. So some of you might be familiar with the public Terraform module registry. In Terraform Cloud and Terraform Enterprise, you can create your own private module registry or PMR, and that's what we see here. And that's the same, the reason people do that is for the same reason that people have private Docker registries, right? If you're using Docker, generally you don't want to be getting, especially in production, you don't want your Docker images coming from Docker Hub. You have them in a private repository, Docker repository, to make sure that you can control them. So what you do is you can have your own modules in your own private module registry. And then what this policy does, and this one I created the old way where it was in the editor. What this one is doing is this is saying, first of all, I have two rules. I have one that says no resources in the root module. I'll make that bigger. This is saying if the length of tfconfig.resources, it should be 0. Either it's 0 or not. I end up then printing an error message. It's a little confusing here about the or not, but basically this is requiring that the length of the tfconfig.resources should be 0. In other words, there should be no resources in the root module. And then the second rule is saying require all non-root modules to come from the PMR. And the way this one works is this one says, hey, all tfconfig.modules, and then it breaks them out by name and M representing the module. And this is using the strings import to say that the M source, the source of the module, has to start with the address of the server I'm running on, which was up here, was app-terraform.io, and then has to include / plus the organization, which I had also set here, cloud operations. And saying that, if you know about how module sources work, when you refer to a module in the private module registry, it's always going to start with the address of your TFC server plus the organization name. So these two rules together guarantee that all non-root modules come from the PMR. And so of course you can control what resources are in those modules. And then you're also prohibiting resources from being created in the root module. And that gives you what you wanted. And then we combine the two rules together here, right? We're
Right.
printing something, but we're basically combining those two rules in the main rule.
Okay,
Here.
Roger, we got one more question that someone
Sure.
kindly submitted. So last question, are there any webhook integrations?
Terraform has webhook integrations. It's not so much for Sentinel, that's a separate thing, but we do in Terraform, there is something called Terraform GitHub. Well, it's Terraform GitHub Actions. Oh, sorry, Webhook. Sorry, that's a little bit different. That's under notifications. So if we look at, there's something called notifications. I'm not sure where the. I hope that's not under. Oh, you know what? I don't think that's limited to enterprise. Sorry, I didn't want to do that. Let me go back. There is something. Let's just see. I hope it's not under enterprise. I know I saw something about notifications. It should be under cloud. So let me see if we can find this really quickly. We have, maybe it's under workspaces. Notifications, there we go. So under workspaces, run notifications. There's two kinds of run notifications, I believe. You can do Slack notifications. In other words, if you're trying to notify in response to things happening within Terraform runs, there's an API for configuring that. But I think you have two kinds. You can see here in the UI, you have webhook notifications and Slack notifications. Now those are notifications in response to things happening within the overall, within runs, right? Things happening within workspaces. That's different from webhook notifications directly on your source code within your repository. But one more thing I should really point out that's important is there are 3 workflows for working with Terraform Cloud and Terraform Enterprise. These are the UI VCS driven workflow, the API driven workflow, and the CLI driven workflow. This UI VCS driven run workflow is the one that I showed you. What happens in this, what this means is normally your workspaces are tied to a VCS repository like the ones I had. And that means that when you do pull requests and merges or pushes on your repository, that will trigger runs within Terraform Enterprise. So if that's what you're looking for, if you're looking to, hey, when I make a change to my Terraform code, at least on the master branch or whichever branch I'm pointing at, I want that to trigger a run in Terraform Cloud. That already is part of our integration with the VCS systems.
Great. Okay, Roger, that's all the questions. Thank you for going through all those questions in such detail for everyone. Y'all probably noticed Roger is really our in-house Sentinel expert, so we're lucky to get his time today. So as I mentioned at the beginning, this Hangout was recorded and we will make the recording available on our website after processing. I'll send an email out to everyone who registered with that recording link. And then also, if you liked what you heard today and want to start exploring Terraform, I encourage you to check out our Learn site. You can find all sorts of resources through there, and it's learn.hashicorp.com/Terraform. And you can also sign up for Terraform Cloud, as Roger mentioned today. So I hope you all enjoyed today's Hangout and have a better understanding of Terraform's cloud feature, Sentinel, which lets you implement governance policies as code. Thanks for hanging out with us today, and a big thank you to Roger for his time. That wraps things up for us. Have a great day, everyone. Goodbye.
Thank you, everybody. Thanks, Amanda. Bye.